Hello everyone, this is Malugna Urganti. This video is based on stock market prediction. In this video, we compare between two models, that is time series analysis and linear regression models, and analyze which model is better in predicting the stocks. In this video, we go through the following steps. First of all, what is stock market? A stock market or share market is a collection of markets where exchanges takes place. Exchanges like buying, selling, issuance of shares are taken place publicly. A stock exchange is a place or organization by which stock traders can trade stocks. This stock market brings together hundreds of thousands of market participants where they wish to buy and sell shares. In this process, each company would like to know how their stocks prices gonna be in future. So this stock market prediction is the process of forecasting the stocks based on the previous stocks, and this helps companies to predict how their shares gonna be in future. In this, we take 5 companies as a data set like Amazon, Apple, Microsoft, Google, and AutoZone. Here we can see how Google, Amazon, AutoZone have a big closing prices, and Microsoft and Apple has less closing prices. For example, Apple has 150 millions as closing prices, whereas for in here for Amazon it has 1,000 millions as closing price. In this, we take these two small scale companies. In this, we take these two which has less closing prices, and these three which has more closing prices. In this, we take these two which has less closing prices, and these three which has more closing prices. First, what is regression? Regression analysis is a statistical tool for estimating the relationship between independent and dependent variables. By using regression, we can forecast the data. There are several regression models available in the market like linear regression, multiple regression, ridge regression, etc. However, in this video, we are taking linear regression and time series analysis into consideration. This regression model helps the stock market companies to know how their stock's price gonna vary in future. First, what is linear regression? A linear regression is a linear model that uses one independent variable x to predict the outcome of the dependent variable y. The linear regression uses regression line to know the relationship between x and y. The linear equation that fits the predictor x and target y is y is equals to beta naught plus beta 1 x1 plus u. Here y is target variable, that is output variable, x is predictor, that is input variable, b naught is intercept, b1 is slope of the line, and u is the regression residual, which is used to represent the error stream occurred while predicting the output y. Here we can see the prediction of linear regression of company Google, and how this orange line shows the prediction values, and we can also see how it is varying. To know if this linear regression is efficient or not, we'll see in upcoming slides. Next, time series analysis. Time series is a collection of data points collected at constant time intervals. Depending on the frequencies, time series intervals can be of yearly, monthly, weekly, daily, hourly, etc. There are different components of time series. Trends. In this, movement can be relatively higher or lower values over a long period of time. If pattern is upwards, it is known as uptrend, and lower, then it is known as lower trend. Next, seasonality. It is basically upward and downward swings, but this is a quite different. It's a repeating pattern within a fixed period of time. It can be irregularity, which is a noise or erratic in nature. It is unsystematic and also called as residual. And time series can be cyclic pattern. It is a repeating up and down movements. It doesn't have a fixed pattern but can happen anytime, like for 6 months, then 2 years, etc. Out of all the components, time series require the data to be stationary. If time series have particular series over time, there is a probability that it will follow the same pattern in future. Hence, a time series analysis strictly follows stationarity so that the repetition of the pattern doesn't happen. In order to be stationary, the dataset should follow following criteria. First, it must have constant mean. That is, it should have a constant mean according to the time. Next, constant variance. The variance should be equal at different time intervals. Next is autocovariance. And this autocovariance should not depend on time or it should be equal. These three criteria are very important to implement time series analysis. In order to know if the dataset is stationary or not, we use a statistical tool named Dickey-Fuller test, which is used to test if the data is stationary or not. In this Dickey-Fuller test, it takes null hypothesis as non-stationary, that is time series as non-stationary, and it returns value like p-value, critical values, and test statistics. By analyzing if the p-value is lesser than 0.05 and if the critical value is greater than test statistics, then we can surely say that the test statistic is non-stationary. Here we can see how our dataset is. Amazon, Google, and all. We can see the pattern. Like for Amazon, the trend is going very high, and we can see that there's no constant mean or variance. And coming to the green, that is Microsoft. Here, since it is very zoomed graph, we may think that it has a constant mean. However, by seeing the Dickey-Fuller test, we can observe for Apple that p-value is greater than 0.05, which shows that it is not a stationary. After performing a lot of transformations and scaling, now we can see how the data became stationary. Here the uh, example for Apple, how the data became stationary. We can say now we can say it is stationary because of the p-value, how p-value is less than 0.05 and critical value is greater than test statistics. The same thing with other companies as well. So now we have transformed all the data and data became stationary. Next, to implement this time series analysis, we use ARIMA model, where ARIMA model is a combination of two models, that is autoregressive AR and moving average MA. These both are integrated by I, that is the correlation between the previous time period to the current time period. This is also a kind of linear regression, but this uses predictors depend on the three parameters called P, D, Q. Here, P is the autoregressive. It is caused because of time-dependent nature, where yt is dependent on its own lags. Yt is alpha plus beta 1 yt minus 1 plus beta 2 yt minus 2 plus so on plus e, where yt minus 1 is lag 1 series, beta 1 is the coefficient of lag 1 and alpha is the intercept. Here the max lag in the model is referred to as P. Next is moving average, Q, where it is caused due to the irregularity or noise. Here yt depends only on the lagged forecast errors. It happens because of the irregularity or noise. Here yt is alpha plus epsilon t plus psi 1 epsilon t minus 1 plus so on. In this, the current error depends on the previous with some lag, referred as Q. We use this other term called integration. Here, integration is order of differentiation. By combining these three P, Q, and D, we can implement a Riemann model. To know the value of P, we use autocorrelation function graph, and as well as to know the value of Q, we use partial autocorrelation function graph. And the value of D is known by using how many differentiations we are doing. Here we can see the autocorrelation function and partial autocorrelation function graphs. Here we observe that the graph is cutting at 0 at point 1, and here also the graph is cutting 0 at point 1. So the p value must be 1 and next q value must be 1, and in this data set, since we are differentiating for only one time, d value is 1. In this graph, we can see the prediction of time series analysis for Google company. Here we have just taken 10 days as prediction. Here blue value is actual values and brown dashed value is predicted values. Now, just by seeing these graphs, we cannot say which model is better than the other. Hence, in order to distinguish between the models, we perform RMSE. This RMSE is square root of variance of errors or residuals. It takes the square root of the mean squared error. It shows the standard deviation of the differences between the predicted values and the observed values. It is an absolute measure of fit. This RMSE helps to represent the large number of deviations with the help of square root. The squared nature of this metric helps to deliver more robust results, which prevents cancelling the positive and negative errors. This metric aptly displays the plausible magnitude of error term. This also avoids the use of absolute error values, which is highly undesirable in mathematical calculations. When we have more samples, reconstructing the error distribution using RMSE is considered to be more reliable. As compared to mean absolute error, RMSE gives higher weightage and lesser errors. Here is the equation for RMSEs where yj is actual value and yj cap is predicted value and n is number of observations. After performing linear regression and time series analysis, here we can see how RMSE values are for ARIMA and linear regression. Here for Amazon, RMSE value for ARIMA is 2.99, whereas for linear regression it is 2953. For AutoZone, ARIMA value is 14.16, whereas for linear regression it is 229.85, which is huge. By comparing this, we can clearly say that RMSE values are very high for linear regression. The lesser the RMSE value is, the better the model is. Hence, by seeing this graph and table, we can clearly say that RMSE value for linear regression is very high, and that is, the error rate is very high in predicting the stock price. Hence, we conclude that ARIMA is the better model. In this video, we have seen how linear regression finds the relationship between the two variables, that is time and stock price, and how time series analysis, which is also kind of linear regression, by using stationarity into the account, how it improves the stock prediction. After predicting both of them and calculating the RMSE values, we can clearly say that time series analysis is better model. For more improvements, here we have just taken two regression models as consideration. In future, we can take the other regression models like lasso, ridge, regression, etc., and analyze which model is better than all of the other. We can also take different evaluation metrics like MAE, MSC, adjusted R square into consideration as improvements. This was the project on stock market prediction. If there are any suggestions or questions, please comment below. Thank you.